Hi, it's Alex with VitalSim, and in this video I'm going to give a quick introduction to railroad switches and how they're simulated in VitalSim. Okay, so just to start from the basics here, so we're talking about a railroad switch where you have one piece of track going straight through and another that diverts, and you'll typically have some way of moving the railroad track. It's called the points, the part that actually moves between one position and the other, so that the train either passes straight through or is diverted. So this is what's called the reverse position. So here you would call this, this is actually the normal position. This is the reverse position. So in this case, we can see the train's diverting. If it enters here, it would go down on this lower track with the switch machine pushing upwards. And then here, with the switch machine pulling downwards, the train would pass straight through. So this is the normal position. So this is a hand throw switch, and that means this is not electronically controlled. So this might be controlled by someone who actually manages this switch physically. So you'll walk over there and move the lever, and it can divert it from either reverse position or normal position. Okay, and this is an electric switch. So you'll have the switch machine here, currently in reverse position and pushing upwards, and then the machine can retract, and now you have the train passing straight through without being diverted. So an important difference between electrically controlled switches and hand throw switches is that in this case, your controller might have some feedback to know the position of the switch, but it will not be able to actually drive the position of the switch. Whereas in this case, your controller can send a command to this switch machine and actually cause the position of the switch to move. So this is important in simulation because in this case, typically for the simulation, you'll want to configure it so that it's manually controlled as the simulation is running. You can say it's either in one position or another. Whereas in this case, you may want to configure it so that this switch machine is actually reacting as it would in real life and moving those points. And so you don't have to manually control those I/O to tell it that that position has changed. Okay, so an important idea when we're talking about switches is correspondence, and that's essentially whether the machine is in the position that it wants to be in. So for example, if we're trying to divert and there's a rock blocking the points from moving to the final position, then it will not be in correspondence. Whereas if it does hit the final position, then it is in correspondence. So you can even be more specific. You can describe, you can call it normal correspondence and reverse correspondence. And what that means is if it's trying to move to reverse position and it arrives in reverse position, it's in reverse correspondence. And if it's vice versa, if it's trying to go to normal position and it arrives in normal position, it is in normal correspondence. And the notion of correspondence can actually be even more detailed than that. So sometimes there will be a check that not only is it in the target position, but that the GPI or the I/O are giving consistent feedback, which means in this case that it's not saying it's in both positions at once. So for example, to be in normal correspondence, that means that the machine wants to be in normal position. It is reading that it is in normal position, and it is not reading that it is in reverse position. Okay, so I think that's a basic idea of how they look. So let's take a look at them in simulation and see how that works. So here we have an end of siding, and there's a switch number 3 right here, which is currently in reverse position, so it's diverting. Now let's just take a look at the configuration for that switch icon. So these switch icons, they can essentially visually represent the state of the switch in a lot of different ways. And that's based on the configuration in these fields, which are typically tags in your programs. Okay, so if we take a look here, essentially we have normal and reverse requests. And these are basically the tags that are going to be picked when you want the switch to move, when you want to command it to go from one position to the other. And obviously that's only going to make sense if you have a request for it. So a hand throw switch, I think, would not have a normal or reverse request typically. Internal status, this is correspondence. So this is the tag that's going to be picked when it's in normal correspondence, and this is the tag that will be picked when it's in reverse correspondence. And then we have the switch machine outputs, and these are essentially physical I/O, which command the switch to move in a certain direction, and then get feedback as to whether it is in that position or not. So these are the tags which, if you want the software to simulate it, they can actually be driven partly by the VitalSim application, or you can say hands off and just handle these switches, these tags yourself. So for example, if you want to simulate some specific behavior of a switch, maybe a particular delay or some jitter in these tags, then you might want to control those values yourself. Whereas if you just want the outputs to follow the inputs, you can tell our simulation to do that. So right now, I've got our simulation, I've got the VitalSim simulation configured not to follow the requests. And so let's just take a look at that, so that's this setting right here. Make switches follow request. And if that setting is checked, then the switches will be simulated as moving in the direction of their request. Whereas if that switch is not checked, then you'll just have to implement that logic manually yourself. So let's take a look at how that looks. So simulation is running. We can see this switch is in reverse position. Now let's set the request to get it to move into normal position. So we'll disable the reverse request and enable the normal request. Now we see here that it's gone red, and that means that it is not in correspondence. And that's because we've asked the switch to go to normal position, but the feedback is indicating that it's in reverse position still. So let's fix that up. Okay, so we can see here, if we want it to be in normal position, the input 1NWPR should be picked. And we can see now it's in correspondence, and that means that the switch is in normal position and the request is in normal position, so everything looks correct. Okay, so now that I've shown you what it looks like to drive that logic manually, I can show you what it looks like when the simulation causes the switch to follow the input, follow the requests, I should say. Okay, so now we take a look here, and we'll make a request for this switch to go into reverse mode. And the request is C1RWS. And we can see there it flashed out of correspondence briefly, and then the switch followed the request, and now it's back into correspondence, and I didn't have to manually manipulate any logic values. Okay, so hopefully that was helpful, and please leave any comments if you have questions, and remember to like and subscribe. Thank you.